Thank you. Morning, everybody. So my research interests are on how transport impacts the environment. And so we can think of that both in terms of a global scale, where transport is a major contributor to greenhouse gas emissions globally, and at a local scale, where transport contributes to severe air pollution problems in major cities around the world. We typically think about these impacts on an aggregate basis. We typically think about average population densities when we try to quantify the impacts of air pollutants on health. And a lot of my work goes into understanding the detail. So we know, for instance, that children living and going to school next to busy roads suffer from where they go to school and where they live. Oops, there's timings on here as well. I'll just adjust this. So, as I was saying, my work focuses on the detail, and we understand from health evidence that different people have different levels of exposure to pollution, and that has real consequences on their health. So children going to school in polluted areas have smaller lungs, and that impact stays with them throughout their lives. We also know, for instance, that taxi drivers, because of their sort of exposure to vehicle emissions in front of them, will be exposed to higher levels of concentrations of pollutants in the cabin. So at this point, you might be thinking that, well, electric vehicles are going to come along and they're going to solve all of our problems. And it's true that on a life cycle basis, they do reduce greenhouse gas emissions compared to conventional vehicles. But that does depend significantly on our electricity grid. And our air pollutant emissions from electric vehicles are not zero. They still have emissions from the brakes and tyre wear. And also their sales are roughly only about 1% of total vehicle sales at the moment, although that is rising rapidly. So the big challenge for the transport sector is growth. The World Bank predicts that by 2030, so only over a decade or so from now, that passenger mobility globally will increase by about 50%, and global freight volumes will increase by 70%. So this puts us into quite a deep hole when we're considering the air pollution and climate change as the two primary environmental problems facing the transport sector. So what I'm going to do is I'm going to talk about climate change first, and then talk about the research we're doing on air pollution and transport's contribution to that, and then kind of bring that together into, I think, how we should start to reimagine the way we think about transport systems. So the first thing is a quote. And the quote says, "We have no room to build anything that emits CO2 emissions." So this isn't a quote from some radical environmentalist. This is a quote from Dr. Fatih Birol from the International Energy Agency. And he said this towards the end of last year. So admittedly, this was in the context of power generation, but with the advent of electric vehicles and the growth of that sector, the two, electricity and transport sectors, are becoming more intertwined. So what I want to do is just focus on some key messages from the latest IPCC 1.5 degree report. And I think this really sort of sharpens the focus on climate change, which can tend to seem like something far away. So the IPCC had a few key messages from their report. So one is that humans have warmed the planet by around about a degree on average global surface temperatures. There are significant benefits to limiting warming to 1.5 degrees in terms of the benefits in terms of mitigating the worst effects of climate change. But that means we need net zero emissions by mid-century. So I'll repeat that. We need net zero emissions of CO2 by mid-century. Okay, that is a huge challenge based on where we are today, and will require unprecedented and deep emissions reductions across all sectors. Specifically to transport, that means the low emissions energy consumption will rise from about 5% today to about 35 to 65% by 2050. So again, unprecedented scale of change. And we also need to combine technology advances with demand-side measures, as this improves the likelihood that we achieve this 1.5 degree target. So I'm going to run you through some arithmetic, and we're going to imagine the world as a pie. And if we're really environmentally friendly, we'll consider this as a vegan pie. So our total pie size, right, that's our total carbon budget, is roughly 2,770 gigatons of CO2. So this is the amount of CO2 that we can put into the atmosphere in total, and that would lead to a 1.5 degree warming by 2100, or at least a 67% chance. So if we want a 67% chance of not going above 1.5 degrees, we have to limit our total cumulative anthropogenic, so human-generated CO2 emissions to this number. So where are we with respect to this number? Well, here's our pie. We're about there. So we've already, as humans, emitted 2,200 gigatons of CO2, which means we have about 570 gigatons of CO2 remaining. And if we do some maths, we can work out, based on our current emissions rate, how many years left of emissions at the current level we've got. And that works out to be about 13 and a half years. So that's not 13 and a half years until we need to start acting. That's 13 and a half years until the emissions that we are currently generating on an annual basis will take us uncontrollably to 1.5 degrees Celsius. Okay, there won't be anything we can do about that. So if we don't achieve it, then we can borrow from the future. We can take a loan out, and they call that overshoot. So we could borrow from the future, but what that means is that we would then have to remove CO2 from the atmosphere. So we'd actually have to physically take it out, which is expensive, and, well, yeah, probably the most expensive way that we could try to mitigate the effects of CO2. So the key question is, what level of CO2 emissions reduction is required and by when? We need to cut emissions by 45% by 2030. That's not very far away. And net zero by 2050. Again, that's not very far away. From a UK perspective, why is transport important? Well, it's the single most, the single largest sector contributing CO2 emissions in the UK. It's also the fastest growing, and it's also the one with the highest risk in terms of decarbonisation and a significant policy gap. So this chart on the right-hand side shows the projection in the black line of where we need to go. The green area is policies that are low risk. The yellow areas are policies that have been assessed as medium risk. The red areas are high risk. And then that red hashed area is policies we don't even have in place yet. So that red hashed area is the gap that we have in order to achieve that black dashed line. So in terms of CO2 and climate change, transport is significant, and we have a significant gap in how we're going to achieve the targets. How about air quality? So air quality is a different issue in that it's much more local, and in certain circumstances it's an impact of the environment on us that we can feel more immediately. So a lot of my research is on understanding the spatial and temporal distribution of these air quality impacts. And we're looking particularly at hyperlocal scales, so that can we inform pedestrians or people walking around cities better routes to travel, for instance. So my research is focused on how much transport emits, and then where and when those emissions occur. In terms of the how much, we do a lot of work in understanding real-world vehicle emissions. And the chart on the right-hand side shows the results we had when we looked at 150 vehicles, showing on the sort of vertical axis the NOx emissions, so that would be the air pollutant emissions, and then on the horizontal axis the CO2, so greenhouse gas emissions. So what we can sort of observe from the general trends is that gasoline or petrol vehicles have much lower pollutant emissions, NOx emissions. Diesel engines, as we know from Dieselgate, have much higher NOx emissions, but they tend on average to have lower CO2. So there's a trade-off. If we start to sort of all shift to buying petrol cars, while that might benefit air pollution, it's going to have a significant impact in terms of CO2 from the transport sector. We looked at a couple of hybrids, and they performed reasonably well, both in terms of pollutant emissions and CO2. So this topic's about machine learning. A couple of instances where we are using machine learning is we're breaking down this pollution. So these are the sort of trip average values, but we're looking also at what happens on a second-by-second basis in a car. And you can think of that as the emissions being the output, and we have some inputs which are like the accelerator position, or how a vehicle is being driven, what its speed and acceleration are. We're using those, and we're using neural networks to build up models of emissions that work at a very high resolution, both in terms of time and space. In order to understand what vehicles are doing, we're using machine learning to count vehicles here. This is a road in Cambridge where we're counting vehicles as they pass by, but also we're distinguishing between cars and trucks, and we're able to get a trajectory of the vehicles. So we can start to look at how vehicles are accelerating and decelerating, how their flow is being affected by congestion, and then combining that with our emissions models to get a much higher resolution picture of where emissions are occurring. If we do that around South Kensington, so South Kensington Station is around about where it says South Kensington. Imperial College is just towards the top, but underneath the Royal Albert Hall. We can see that transport emissions are not homogeneously distributed around cities, but they're concentrated around intersections. And these are the areas that we need to, or we could inform people to avoid. Okay, so one take-home message: if you're going out for a run this evening or any other evening in London, do avoid major intersections and major roads. So these are the emissions. What happens when they sort of get dispersed in the air? This is something we're looking at with computational fluid dynamics. So we're looking at how in this relatively simple intersection, the dispersion of pollution is actually a very, very complicated picture. So in this simulation, we have different lanes with different types of vehicles, using those different lanes just to illustrate the issue. And we've also incorporated how the vehicles actually affect the flow themselves. So how the vehicles induce turbulence and induce dispersion. And what we can see, if we sort of just play that again, the buses that come from the right-hand bottom corner, as they travel up the road towards the top left, they actually entrain pollution up the road with them. So they sort of drag it up there with them, which is something that we hadn't sort of previously observed when we have not previously taken into account the movement of vehicles. And if you've ever wondered what it's like in terms of pollution to be standing at a bus stop, then have a look at this video. So this is a bus coming towards you. The green plume is the emissions of nitrogen oxides, and you soon become enveloped as you're standing at the bus stop. This is real data from TfL using their sort of buses that have been fitted with NOx sensors, and we've got real position data. And then the simulation is of how those emissions are dispersed. So how do we bring it all together? Well, actually, if we sort of think about climate change and air quality together, then a lot of the solutions that we come up with help both of those challenges. So there's significant both co-benefits in terms of the solutions that we propose for transport benefiting both air quality and climate change. Now, this is an Imperial Business Partners event, so I couldn't avoid putting the bottom right-hand side picture, which shows that there's a significant business opportunity for low emissions vehicles, technologies, and particular strengths within the UK in terms of connected vehicle technologies, low emissions vehicles technologies, etc. If we want to break this down a little bit more, how can we start to come up with the solutions that will reduce transport's impacts? Well, we can think about the total emissions of transport as a function of 4 factors. So the total amount of activity or mobility, the occupancy of vehicles, so how many vehicle kilometers are traveled per passenger kilometer traveled, the energy intensity, so how much energy we use per vehicle kilometer traveled, and then the carbon intensity of the energy vector that we might use. So currently the majority is fossil fuels, but we might be thinking about hydrogen or electricity. We can think about all these 4 factors as 4 levers that we can adjust to try and change the impact of transport. And my argument is that we need to start thinking about this in an integrated way. So we need to consider how demand will affect mobility and also occupancy rates, how vehicle propulsion and fuels affects occupancy and energy intensity and carbon intensity. How can we integrate that with thinking about operations and infrastructure? And then there's a whole piece around systems integration. So why do we need to think about this? Is because that we know, and there's evidence for the fact that in dense cities, people travel less, they travel on public transport, and in high densely populated cities, there is a lower amount of CO2 per passenger kilometre generated. In terms of thinking about future technologies and the advent of autonomous vehicles, that could impact on the cost of travel. So a travel cost reduction could induce us to travel more, and there could be a sort of negative impact of that in that we travel more, consume more energy in terms of transport, and produce more emissions. However, if we think about it in a connected way, we can start thinking about how to perhaps match specific vehicles for specific trips. So if we have one person who wants to travel a distance, we don't need a car that can seat 6 people to take them. We could send a car that needs 1 person. So it's those sorts of ideas that we need to be thinking about. So just to sort of quickly show you that we are working with industry in terms of research, and sort of one project is looking at how operators can incorporate hybrid electric trucks into their fleet and how to optimize the number of vehicles that they would purchase. We're also looking at real-time vehicle emissions using these neural network techniques for modeling emissions, and then mapping that in real time to give guidance to policymakers. Thank you very much for listening.